everyone. Thank you so much for spending the time this evening to come along and listen. Andy Thomas, as Tony alluded to, I'm the one waving, by the way. I'm a lead architect for AWS. I concentrate on public sector customers, and yes, my day job does involve the Department for Work and Pensions, and hence the link to Tony. So I'm going to just knock my camera off just to kind of be respectful for my bandwidth here, and hope we don't run into any problems with that, or ice cream vans outside the window, or any of those kind of things we get with these virtual meetings. So our topic today is Amazon Web Services, known as AWS, and what we're looking at in terms of sustainability around cloud computing, what that means to AWS itself, and what it might mean to people like yourselves who may be looking to use AWS, or indeed another major public cloud provider, because many of the things we will talk about this evening are applicable to them as well. So first of all, I thought I'd try and set some context for this in terms of what we're trying to address, to kind of set the stage, as it were. Now, I'm not a scientist, but I gather our scientists tell us that we have a limited window, as it says on the screen here, to make an unprecedented headway, and I'll kind of try and clarify that for you as we kind of go through this, to limit global warming to 1.5 degrees C by 2050. But what does that actually mean in terms of a target? Let's try and quantify it a bit. So if we're going to get to net zero carbon emissions by 2050, one of the things we have to do, if we can, is halve our emissions by the year 2030, which isn't that far away. But what does that mean? So to put that into some more context, that means a yearly reduction of between 5 and 7% of the greenhouse gases that are emitted around the globe. We have actually done that. So we did that in 2020. But of course, 2020 is a year that I'm sure many of us will always remember in terms of the deserted streets and the deserted skies and the many other things, many of them quite tragic, that happened in that particular year. So we certainly don't want to repeat that year in those terms, but we do, if we can, want to repeat that year in terms of what it might mean in terms of our overall mission in terms of sustainability. So probably a good place to start, be it for a corporation, a public sector body, which I work a lot with, or indeed as individuals, is to start asking some questions around this. So can we identify our hotspots? Can we think about the resources we use in our corporation, in our business, in our daily lives, the kind of resources we're using, and how we might minimize them for living our lives as we want to live them today? In terms of a business context and IT context, being able to innovate faster will certainly help, and we'll hopefully try and clarify that for you as we go along. And how do we collaborate and work with others as well? Because as we'll see shortly, that this is quite a big problem. It really does touch more than just your immediate surroundings and your immediate business in terms of trying to address this. So again, trying to put some things into context for us. So we are apparently emitting 50 gigatons of CO2 or CO2 equivalent every year. And in terms of the industry that I'm here to talk about this evening, and I guess most of us are involved with, when you look at information and communication technology business, we're responsible for a proportion of that. An exact figure is quite hard to come by. It's probably between 2 and 4%, depending on how you measure and who you talk to, but it's that kind of order of magnitude. And then in terms of actually clarifying what that actually means, there is something called the Greenhouse Gas Protocol, which has become a pretty much standardized way of actually measuring this and understanding what it is actually about, and how we kind of look into it. And the Greenhouse Gas Protocol looks at 3 scopes. I would say straight away, and you'll see very shortly, that 2 of them are relatively easy to get a handle on. The third is somewhat more difficult. There's a little link there, and there'll be many links during this presentation where you can kind of click through and get more information on the kind of things I'm talking about. So scope one, simply put, is quite easy to understand. So this is about everything that all the sort of fossil fuels or gas and so on that you actually burn to do yourself. So things that you're burning in your car for your personal journeys, you might be doing in your fireplace, or I'm not sure, many houses will have a furnace, but I guess some industries would have what's coming through the gas meter, and you're actually burning that on premises, as it were, or in your own kind of environment. Coals on the barbecue would be another example of that. So it's the direct emissions from the fossil fuels that you're kind of burning directly yourself. Scope two looks at the kind of stuff that's coming into your premises that you're actually getting from the grid. So typically some kind of a power station, or hopefully some kind of renewable energy source. And if we can, to minimize this, because it gives us a chance to switch to entirely renewable energy sources, if we can, we try to electrify everything. So whether that's electric cars or induction cookers at home, or other examples within the industry, that you can, if possible, switch to an electric source for all this kind of stuff. And then finally, the scope three emissions, with a very simple diagram of a very complex problem, is thinking about everything that supplies your industry or enterprise. So everything that comes through the door, where it comes from, and how is that impacting the environment? How are we dealing with waste? How are we transporting things, and so on and so forth. And then also on the right hand side, if you're kind of selling goods or shipping goods, then what's involved in that, and what's in that process, and all the things that are involved with it. And if you take a look at the greenhouse gas protocols kind of website, you'll find this diagram not too far from the top there. And you can see when you look at this diagram, if you look at scope one and scope two, they're relatively simple. But all the stuff involved with scope three, you begin to understand that there's an awful lot involved in actually understanding that. And one of the challenges we have, one of the things that's emerging in terms of capabilities in this space, is services and tools and products that allow us to do all the data modeling that's involved in all of that, and understanding it and being able to manipulate it in some way. And we might hopefully get some time to see one or two examples of that later on in the talk. So then moving on, looking at data centers in particular, because AWS, Amazon Web Services, we are very much concerned with what happens in data centers and what we can do to actually improve things there. So those three scopes do affect us. So as you would expect, there's quite a lot of electricity coming into our data centers. We run very, very large data centers with very many tens of thousands, hundreds of thousands of servers, and millions of compute cores and everything associated and around that. So a large energy consumer. We have some scope one emissions going on in terms of if we're ever required to fire up our backup generators because there's been some kind of incident in the local area, then we'd certainly be responsible for some scope one stuff, and an awful lot of scope three as well. So we are very concerned with how we construct our data centers and the type of concrete we use. And we're also very concerned with our supply chain for the equipment that goes into those data centers to actually make them work. So AWS very much has a focus on all of this, and we have responsibilities in each of those areas of scope that we talked about. So AWS then has a shared responsibility model. So anyone who's ever worked with either Amazon Web Services or any of the other major public cloud providers might be familiar with this concept. So from a security point of view, AWS itself has some responsibilities around securing the AWS platform. And you as consumers or customers of AWS, you also have a responsibility for the things you build on top of it to make sure that they are appropriately secure for your business or your use case. And we've now extended that idea, or taken that idea and taken it into sustainability. So in terms of what we call sustainability of the cloud. So AWS has responsibilities, of course, for the servers and other compute and networking stuff we run in the data center and making that as efficient as it possibly can be, of looking at how we cool our data centers, whether that's with water or with ambient air. And also looking at where the water comes from and how it might be recycled, and can we take wastewater from the surrounding community and use that to cool our data centers and process it on site. Looking at the waste chain, that things that leave our data center and what can be recycled and so on and so forth. And of course, a big focus on the energy that's associated with all of that. And of course, where we can, look at new building materials as well. Given the size and scale of the AWS business, we're able to do things there that perhaps is not available to other organizations. So in terms of, one of the big ones, renewable energy, AWS has a target to use 100% renewable energy by the year 2030. And we think we might be able to do a little bit better than that as well. So in terms of sustainability of the cloud, we have signed up to the Climate Neutral Data Center Pact. So AWS is a member of that, where we have said we will try to meet these goals that we've talked about. We will be as efficient as we can be in something called PUE, which is a measure of how efficient our data centers are and how much emitted heat is involved, and making sure we're setting the right standards and targets and goals to ensure that we meet our sustainability targets going forward. We've also, just get control of my mouse here again, there we go. We've also signed up to the climate pledge. AWS has and is investing $2 billion in organizations and inventions and kind of other things around AWS, investing in them if we think they can help us meet our goal, and that kind of money is already being spent to help us there. We do, as I said, we do have a net zero carbon for Amazon in general, and AWS itself, in terms of its data centers, we are currently on target to use 100% renewable energy for the AWS data centers around the globe by 2025. And as it stands, we are the biggest corporate buyer of renewable energy in the world today. So we've already made significant strides towards the objectives already. And just summarizing some of that already about where AWS are in its journey in terms of trying to make the cloud itself as sustainable as it can be. Lots of work with water in terms of evaporative technology and making that as efficient as it can be. Recycled water we've touched on, and on-site. The 2025 target for renewable energy in the data centers. And then we also do some quite extraordinary things as well. Given the size that we are, and I can't imagine too many people know this, but we actually design our own CPUs. So you'll be familiar with Intel processors and AMD processors that you use in your computers at home and in your laptops that you might be watching this presentation on now. But there are other processor types around that have been specifically designed by AWS. So we bought a company called Annapurna, and they've taken the ARM technology that I think probably most famously for most people you'd find in a Raspberry Pi, and made a server variant of that we use in our data centers. And it's quite extraordinary technology. We're encouraging our customers to use it wherever they can. It has better performance, better price, but crucially, uses far less energy for the same kind of workload and performance than you would find from traditional processors. So we're very much trying to encourage people to do that. We've also had teams looking about how we do uninterruptible power supplies, and we found by actually decentralizing some of those, they are a lot more efficient in their AC to DC conversions than they might otherwise have been. And we've talked about low carbon concrete and so on. We also published in the bottom right hand corner, we also published lots of data sets that are available to you for free, whether they be long-term climate data for temperature and sea levels and humidity and so on and so forth, but also satellite data and imagery as well that you can use, bring those data sets into your own tooling should you wish to, depending on which industry area you're actually interested in. Of course, there's data behind all this. There's been a lot of studies I will leave you again to look at the link, and if you wish, have a look at some of the detail that's in these reports. I think the net of all of this, to try and remember, is we think from our studies and the data that we've collected from around the world and in Europe in particular, that AWS data centers, as they currently are typically about 80% more efficient than a typical commercial data center that a large enterprise might be using, which is a significant, it's a significant improvement on what you might be able to do on your own. So we do encourage, where it's appropriate, for organizations to try and talk to us about moving workloads to cloud, to try and meet some of their sustainability goals. As I said, lots of data there for you to look at, and it it's still an area that we're still researching and still doing more reports on, as you would expect as time goes on. So that's talked a little bit about AWS and given you a flavor of the different things we're trying to do in terms of having 100% sustainable energy through to processor designs that make people a lot more efficient in terms of energy and um, more carbon neutral building materials and so on and so on. But what can you do? Well, that's where the split responsibility model comes in, and we begin to look at sustainability in the cloud. And I have a couple of simple examples and then some more complex examples as we kind of walk through this. So again, the shared responsibility model. So now we're talking about the stuff that's in kind of the top bit there in blue, about how you do data design and how you go about storing and using data. Uh, we're also looking at software application design and what that actually means. How about looking at some code efficiency and the way we do that, and utilization and scaling as well, which is something that is fortunately fairly easy to address in a cloud environment. So, as we said, in the cloud, this is also a continuous and focused effort. We're looking to improve our energy efficiency and reduce our energy consumption across all components of a workload. And when you start thinking about the workloads and breaking this down, it typically has a couple of components. So most workloads will involve some storage, some data transfer, and some compute. You will find that there will be relationships between these. So if you store storage in the United Kingdom rather than Europe, then if your users are in the United Kingdom, that's obviously going to involve a lot less data transfer and energy in terms of the communications devices that are involved in achieving that data transfer. And similarly, depending on how you do your storage, you might be able to drastically reduce the sort of compute you need to actually do the data processing that's involved. There then are a whole bunch of non-functional requirements alongside the resource usage that have to be thought about. And cost will be involved in there, availability will be involved, response time, but also quality of result as well. So if we can compute something, let's do a really simple example, to 2 decimal points, and that's sufficient, where today perhaps we'll just take the default option and be computing it to 30 decimal points, then maybe that's good enough for our business. It kind of depends, doesn't it? So that has to be looked at as well. So there are lots of trade-offs here, which is what all the white arrows are trying to depict, and lots of things that need to be thought about. Now, AWS for a long time has had something called a well-architected framework. So the well-architected framework, we don't really have too much time to explore it tonight, apart from the sustainability pillar, but there are 5 other pillars that explore making sure that you are operating your system in a way that you have full visibility and observability of what's going on. Of course, security, very important in any public cloud, that we secure things appropriately. Reliability is all about making sure we have the appropriate recovery time objective, recovery point objectives for the particular business service that we're running. Of course, we want things to be performant and efficient, and everybody's interested in cost optimization. I haven't found a business yet that's not interested in that. Interestingly, cost optimization is very strongly correlated to sustainability, which is good news for a lot of our customers, because they tend to focus a lot on cost optimization in cloud with AWS, as we do actually. We're always talking to our customers about different ways they can optimize their systems. So there's a link there. You can kind of explore lots more about the well-architected framework in its totality. Let's zoom in a little bit on sustainability. And part of being well architected at AWS, this is not about marking homework. This isn't about AWS kind of showing up and saying, oh, you should have done this and you should have done that. We don't really find that people make bad decisions or deliberately design things in a poor way, whichever pillar we're looking at. What we do find is sometimes some questions are forgotten to be asked. And what we try to do with Well Architect is bring lots of different stakeholders together, those who are responsible at a business level for a particular service, through to the folks who are in operations, who actually have to run this in production for us, through right the way back to the original kind of architects and software design team and the coders, kind of bring them all together and just ask a bunch of open questions about what's going on in their kind of design. And we've kind of collated these questions over a long period of time, that hopefully will draw out risks or things that perhaps have been missed in consideration when a new sort of service is being designed and taken through to production. So we have a bunch of subcategories in the sustainability pillar, and they will ask questions about how are you scaling this infrastructure with user load, which is kind of an obvious one to ask, isn't it, really? If you're not too many users logged on in the middle of the night, then hopefully you're not running 100% of the resources that you might be in the daytime to sustain that load. You'd be surprised how often that happens, by the way. It does happen quite a lot. um, are the service level agreements appropriate, and do they have some sustainability goals in mind? So depending what kind of service or offering you're making maybe to the general public, does it really need to be fully available through the night, for example? Can we afford a little bit of downtime? Um, and even doing our day-to-day operations, can we tolerate maybe a minute or two's outage in an unusual event versus having it fully available all the time? There are lots of questions to be asked there that have impact in terms of sustainability, but of course they also have impact in terms of the business requirements as well, and so on and so forth. So obviously we don't want to be running assets if we don't need to. We want to optimize the placement of data, so that it's I guess in most cases in the UK for our UK based customers, but not always. Some people run global businesses, and we can help position data close to wherever the client actually is for you, and so on and so forth. So that's user behavior. Here's a very simple example I see an awful lot of. You'll perhaps recognize this kind of pattern, but we have a service running. It's currently running on two what we call availability zones. So in AWS speak, an availability zone will be a collection of more than one data centers in a particular geographic area. Availability zone B would be another collection of data centers, and they'll be a significant distance away from availability zone A, so maybe tens of kilometers. And then availability zone C will be another collection of data centers, and they too will also be tens of kilometers away from availability zone A and B. So it's very easy to build highly available, disaster resilient kind of infrastructure on AWS. So this is a typical pattern. I see this an awful lot. We're running it, it's quite a simple example because it's quite hard to do complex examples in slideware. But, we might be running on two availability zones with 50% utilization. We require immediate failover. It's a business requirement. So if anything happens in availability zone A, whether it's a logical error on your behalf or it's something wrong with the underlying AWS infrastructure, we get immediate failover and we run on availability zone B. However, we've got three availability zones here. So a slightly more efficient way of doing this would be to pick smaller, more efficient compute resources, run them at 2/3 utilization. And then if we lose availability zone, we'll take that a third of that, the 2/3 of that workload and spread it over the remaining two availability zones. Now, that is actually a somewhat better way to actually utilize the resources. It may also actually be interestingly cheaper as well, which as I said, is quite often quite a high correlation with cost savings on AWS with sustainability. And then if we can change the business requirements, so we can tolerate maybe a minute or two to do the failover, then we can just run in one availability zone and during an incident, just fail that workload over. So nice and simple examples, and kind of easy to understand, but surprisingly common that we find people not actually doing this or not actually considering what the underlying business requirements are and do they require immediate failover. So one of the recommendations that comes out of the sustainability well-architected reviews to have a good look at the impact of SLAs and can they be negotiated down so they become a little bit more friendly in terms of sustainability. Other things we ask you to look at is hardware patterns. This mainly comes down to looking at the most modern and efficient compute types that we have available within the cloud, things like Graviton, we touched on earlier on, and where, for example, we need to use GPUs, which are co-processors from the likes of NVIDIA and so on, to make sure that we're optimizing those and using them when they need to be used and not at other times. Now, so Graviton, as I mentioned, yep. If you can explicitly use it, then please do. You may also find that you're kind of implicitly using it because of a lot of the higher level services in AWS are also using Graviton under the covers, and we're on a march to kind of switch things over in a fairly transparent way for all of our customers to make sure that we're being as efficient as we possibly can be. And that's all part of our sustainability pledge to make sure we do things like that. Okay, so here's a graph that maybe some folks recognize. So you see we've got a squiggly line with two obvious peaks within it. The first peak might be a very common one. It's midnight. Let's run the backups. A lot of people do that. And the second one might be it's 4 a.m. Let's do our batch reporting job. And it's surprising how many people do things like this. Um, If we can, there are ways to flatten this out. So that might be introducing some jitter and some randomness into this kind of task. And a lot of cloud backup technologies are non-disruptive. So they will take non-disruptive snapshots at the side there, and that won't impact anything in terms of a running system. So perhaps we can spread the backup out across the working day rather than relying what just people naturally do it, kind of schedule things in the small hours to do that kind of thing. So there may be some things we're able to do there. There are also things you can do in software. This might range from kind of obvious things to do in the cloud. We have cloud architectural patterns that involve decoupling services and sending them through queues, doing things in an asynchronous fashion, through to more difficult things like trying to avoid, for our most computationally intensive parts of a workload, using interpreted language or semi-interpreted languages like Python and Java, and maybe rewriting that in Go or Rust or one of these other modern, more efficient languages. And particularly where we're doing some serverless workloads, which may pop up for a couple of hundreds of milliseconds and then completely disappear. That can add up over time to quite a significant saving in terms of the underlying resources that get used. And these are all the kind of questions that we will draw out in a discussion when we're looking at the sustainability pillar in Well Architected. The other thing I might say, which may not be obvious to you, is that when you take everybody's workloads and you're dealing with hundreds of thousands of customers or even millions of customers, which is what hyperscale cloud providers like AWS actually do. Uh, if you take all those squiggly lines and combine them all together, then you tend to find that everybody's utilization will flatten out. So rather than being quite an erratic sort of example that we saw previously, if we combine workloads from many different clients and very many thousands and tens of thousands of workloads, things will tend to flatten out. The scale on the left is nothing like you might expect, though, or might be familiar with your own data center. We're talking about millions of CPU cores. And that tiny little gap between the thick green line and the dotted line, when you're on a scale of millions of cores, that's a big number. So even though it kind of looks like kind of scary in terms of, oh, that's a very high utilization to be running a data center at, or a collection of data centers, in fact, there's quite a lot of resource left between that kind of solid line and the dotted line. A lot of our higher level services that we provide will also help you kind of get get to that kind of utilization model. So let's talk about that for a little bit. A couple of things that you can do that are relatively new ways, well, not so new, I guess, in terms of putting services together that are kind of are really good patterns to do in cloud computing. So if we can, event-driven microservices are really good. So rather than having static resources, so virtual machines or compute of a given size, always spinning, always waiting for the next thing that actually happens, it is possible on cloud to build event-driven architectures that will instantly respond to a kind of key press on a keyboard or a touch of a mobile device or something arriving in our storage, a new file or something that will trigger all kinds of downstream serverless events, which will pop up resources, run your workload for perhaps just a couple of milliseconds, and then it all disappears. It all goes away. And that's a very dramatically different way of dealing with modern workloads and architecting modern systems than the traditional approaches that we tend to have seen on data centers. Containerizing things really helps that. It helps you on the road to actually achieve that. And where it's possible, if you can architect your workload so it becomes interruptible, either by decoupling things through queues or things like Kafka and so on, that really helps as well, because it allows us to use things like what AWS calls spot resources. So that's us controlling for you when we make compute available to you. You running your workload while that is available. So there's a surplus of resources. And then if we suddenly, in our day-to-day workload, things start getting busy again, we'll just hibernate you away. And at a later time, you'll be able to resume that workload. And you might think to yourself, oh, that doesn't sound great for my business, but there are a lot of things in terms of genomic processing, high performance computing, computational fluid dynamics, where that occurs in aerospace or even Formula One racing, and other financial modeling systems where that makes an awful lot of sense. And not least of all, because the cost savings associated with using cloud computing in that fashion are dramatic. So maybe 80, 90% reduction in cost. And it also helps AWS and it helps everybody flatten that curve and make things, make the whole thing a lot more predictable, and helps us in terms of driving the efficiency of these data centers to extremely high levels, much higher than you might be able to do yourself, of course. So in terms of data patterns, that's also part of this. Data classification policies is very important, how you handle data and how secure it needs to be, both in terms of net security, but also in terms of its lifetime and how it's protected. Try to avoid over provisioning of stuff. And again, there are offerings within the public cloud platforms that make this incredibly easy to do compared with traditional approaches. And let's have a look at some obvious things that can go on here. So I would say when I look at my customers and how they use AWS storage, which is called S3, that's our simple storage service for object storage, most people end up on the left-hand side of this chart. They kind of use the default offering, which is spread across 3 availability zones. It's very quick. It has near instant access, and there are multiple copies of your data in each availability zone. If the data you're storing is reproducible, why do that? Why not use maybe the offering in the middle, which is S3 one zone? And as its name implies, we just store multiple copies of your data, but just in one availability zone rather than 3. And that might be perfectly acceptable if you're able to reproduce your data in a kind of meaningful time for your business and your requirements. And again, depending on the type of use case, we may be able to use some of our kind of slower access storage, which we call Glacier, which has its own use cases as well. This is only a glimpse of the data storage that's available in AWS, but there are always choices. And these are the kind of discussions, again, we try and draw out when we talk about the sustainability pillar, when we're looking at well-architected. There's some obvious things you can do. People don't use compression very much. And even those who do use it might use gzip, for example. But there are better, more efficient compression algorithms that are very much available to folks now. So AWS ourselves, you can imagine, we log an awful lot of stuff. But by switching our compression technology in the background, we were able to save an exabyte of storage, which is also almost an unfathomable amount of storage in terms of just logging by switching the way we compress things. You can also be smart in the way you leave data at rest as well. So I see a lot of data lakes or large data stores where my customers will be storing files in a native kind of raw format. So very simplistically, that might be a very large CSV file or a very large flat file that's been extracted from some kind of database somewhere and then it's going to form part of a data warehouse solution down the road. But even if you one-time transform these into some very common and well understood formats such as Apache Parquet, what you're doing there is you're compressing the data, you're putting it in columnar order, and you're also partitioning it by some kind of clever partition scheme within the S3 object store. And instantly, we get orders of magnitude improvements in terms of the amount of data storage we're using, and perhaps multiple magnitudes of order of processing time improvements in terms of actually dealing with the data and actually running some queries against it. And again, it's not that common yet to see people do this kind of thing. And perhaps we really should look at it going forward. And it's kind of, again, another thing we would draw out in the discussion of sustainability through well architected. That also applies to running ACID transactions or time series queries. Why run a database? There are some other options in terms of Apache Iceberg and AWS governed tables, for example, where we take the data storage formats above, add some metadata to them, and that enables kind of serverless technologies for querying the data as well. Not applicable in every use case, but there are a lot of use cases where that would be appropriate. And at a stroke, you just wipe away a whole processing layer, which quite often is continuously running in terms of SQL or NoSQL databases sat above it. And again, the development process, again, this is all about, can we have feature flags? Can we have agile development? Can we have A/B testing? Can we have canaries and so on to make sure that we can quickly iterate and improve our environment in terms of the way we're writing code to process the data, or we're switching from an interpreted language to something that might be a little bit more efficient in terms of being compiled and so on. Okay, so I want to bring you back to this slide, which we showed quite earlier on, which was asking some questions about how do we identify some of these emissions and how do we spot where we're using things and things are inefficient in our supply chain and so on. There is some hope in this space. So there are some basic tools that AWS has, which are trying to look at your existing AWS infrastructure and give you a measure of where you currently are in terms of your CO2 emissions and estimate what it might have been if you'd have left it in a traditional data center. And it'll break it down by service type. So in the kind of left-hand box there, EC2 is our compute service. S3, as we've been discussing, is our storage service. There are then other things you can do. So there are little labs that are part of well architected, which might give you kind of a color bar chart, which kind of looks at all the different compute types you have, or the different storage types that you're using, and kind of highlight them in terms of, maybe the red ones are not so good, and maybe the green and yellow ones are maybe better choices. And it might highlight for you which projects might still be using older compute types, and maybe they can switch across to different types of compute or different types of storage, or even perhaps look at some of the more clever architectures in terms of event-based stuff that we've already talked about. Going a step further, AWS has a consulting arm, which is got an awful name. It's known as ProServe, but professional services, I guess. But they'll go a little bit deeper in terms of drilling into your scope 2, 1 and 2 emissions, and a little bit, a top level look at your supply chain as well, with some visualizations with heat maps and so on to some of the things that might form part of your scope 3 emissions. And then at the top end, and I must say I did wonder about including this slide because it does mention a particular third party, but I should mention that other vendors are available, but this is one I found a public blog post on, which kind of talked about the complexities of addressing scope 3 and doing some really complex data modeling, digital twinning, which once you've gone through all of that will help you in terms of understanding what your supply chain might look like from a geographic point of view, maybe ask some what if questions and see if you can remodel the business and make some changes, what that would actually look like. So there are tools out there. That's one example. There are others as well, which would layer on top and perhaps give you a much more holistic picture of what your organization might look like and how you might be able to manipulate things in the future. So conscious of time, and it is early evening, so I just want to finish, I guess, with a call to action. I would encourage you, either yourselves or maybe by having a look at the well-architected frameworks sustainability pillar, to take those questions, if you like, that are in there and ask those questions about your own sustainability and what you're currently doing in terms of building systems and workloads, and see if some of the things that are in there can apply to you, either in your environment, if it's not AWS, or if you are in AWS, how it can directly apply there. Find the areas, if you can, to prioritize and where you can make the biggest difference in the short term. I guess if we solve the easier problems first, we will all learn as we go along and be able to address the more difficult problems that we typically see in scope 3 in due course. And as the tools and the capabilities evolve to help us address that problem as well. And goodness me, one of the biggest ones of all, I think, and something I see again and again in the larger organizations I deal with in my day job, do collect and share your learnings. It's amazing how many times, as part of my job, which I'm supposed to be like an expert in AWS, but I spend a lot of time explaining to folks in, one group that actually there's a group over there. They'd actually done the same thing, right? And there's a lot of learnings that they can take from them and actually repeat them and not go through a lot of the pain of learning things again. So I would, very much so in terms of sustainability, just share what you've done and share that within your own organization, and where appropriate and you find a means to do it, share it publicly if you can. And hopefully I've done a little bit of that this evening for you in an AWS context. So thank you very much. We've got some links, free AWS courses and so on. You can go and have a look at if you're interested. But apart from that, thank you very much, everyone, for listening. And if there are any questions, I'm happy to try and answer them as best I can.
Well, thank you, Andy. Much appreciated for you coming out in the evening to talk this through. So yeah, Darren's just suggested we use the raised hand feature to ask questions. Okay. So do we have any questions for Andy about this? I mean, looking at the sort of services and the way to look at sustainability in data centers, I just wondered if any, but yes, we've got raised hand.
Okay, so thank you, Andy. That was a really interesting talk. I'm just curious about the processes that you were referencing. So how would a company make use of them? I mean, they've got to select them through the AWS interface, I guess. But in terms of what would run on them, what would they be compatible with?
Yeah, so the underlying architecture is the ARM architecture. So anything that runs on ARM will run on them. So I guess a more easier way to answer the question is, firstly, if you're using any of the high level kind of languages or tools like Python and Java and so on and so forth, they all run on ARM. They're all available. So that should be a fairly easy transition. We do also, as I alluded to, kind of use them in the background in AWS. So if you use any of our managed database services or a lot of our serverless technologies, they're just using them. They're using Graviton in the background, and we take care of all of that for you. So you can kind of utilize it fairly easily.
Okay, thanks very much.
I think, Andrew, do you want to come off mute and ask your question? I think you have your hand up.
Okay, thank you very much for this ample opportunity to ask this question. And thank you, Andy, my namesake, for this wonderful session. I really enjoy every part of this session. And before now, I've had interest in being good in AWS, and this session has also availed me the opportunity to meet with someone that is already into it, and I think it's an ample opportunity for me to ask this question. So having this interest, I want you to advise me on the best way to go about, learning about AWS and acquiring certifications that will help me to, start working with AWS.
Okay. So my advice would be go visit your favorite search engine and type in the words free AWS training, and you should find absolutely loads of stuff. I would also encourage you to have a look at, if you like, it depends how you like learning, but if you like doing things with hands-on, there's workshops.aws. Maybe I'll put it in the chat window now. And there you'll find literally hundreds of hands-on examples of how to use AWS. So I think those two. There's also YouTube as well, right? We have loads and loads of free talks on YouTube. So pick an area you're interested in. So if it's basic compute or writing mobile applications, or is it machine learning? Is it containers? Just pop onto YouTube and enter those kind of search terms, and you'll find lots of talks there that will help you along the way. And if none of that works, come back and talk to us. We'll help you out.
Okay. Okay, that's fine. And in terms of getting certified, what do you advise?
So a couple of things that can assist you there. So first of all, if you're going to do any kind of AWS certification, you've got to get some hands-on. It's essential that you've actually used the platform. There are also various training providers who provide AWS certification courses. Some of them offer free offerings. A lot of them are paid for, I'm afraid. So perhaps through your employer, perhaps ask you, see if they'll support you through that. That might be an appropriate way for you if that's open to you. But yeah, you really do need to do a little bit of hands-on to get through nearly all of those exams, I'd suggest.
Okay, that's fine. Thank you very much. I hope to keep in touch. Yeah.
Sure. Thank you for the question.
Yeah. Cheers.
I can see at least one more hand, but I'm not sure it is on my display who it is.
Hiran?
Yes, it might be mine. I forgot a question about the presentation, but before answer that, having recently just entering the cybersecurity industry and done a boot camp, 3 quick additional suggestions I'd give to Andrew would be courses on Udemy are pretty good, and also have a look for free skills boot camps, which are being rolled across the UK as part of a government initiative, because a lot of them are in cyber and digital. So you might be able to enrolled on a boot camp for free.
Thank you for that.
And the actual question I had was just curious to know.
Thank you very much. Can I get some of the links to these boot camps, please?
I can't. The only 2 I could give you are QA and Firebrand. I don't want to sort of promote them, but Google. I think if you Google and search, you should be able to find it.
Okay, thank you.
The actual question I had, Andy, was just curious. Obviously, you in your day job, you speak to many different organizations and you're trying to help them improve their sustainability. I can guess what I think might be the biggest barriers for people to adopt it, but what do you find or tend to see as sort of the biggest barriers that people, or aversion that they have to sort of adopting more sustainable practices?
Oh, that is a big question.
Yeah, I can imagine. Is there any
I-
common themes, I guess?
Well, I guess the first thing I would say is it's never considered on its own. So as I think I alluded to during the presentation, you know, if you wanted to be as sustainable and you kind of took everything to heart in terms of the sustainability offerings and capability we have, there may and there often are compromises elsewhere. So it could be in terms of running that system 24/7, which might not be acceptable to some stakeholders. It might be that that change in processor technology might bring a little tiny bit of engineering work with it. That might not be, and quite often just the word change, especially in some of the larger organizations, change isn't something to be taken lightly. It has to be appropriately managed and governed to make sure that everything else that goes around all these complex systems are appropriately considered. So I think it's a program of work. I think it's to be done over a period of time. But I think the more aware we are of it, and especially when we're building brand new systems, that's going to be really important going forward, which is why I was really encouraged to see the sustainability pillar pop into Well Architected, because we should be doing that at the inception of a project. So
I was going to add, the framework that I'd seen only had 5, so good to see that it's there now as well. It needs to be more and more, well, almost part of routine, doesn't it? And I think slowly we're getting there, maybe. Yeah. Thanks for answering the question.
Lester, I think you've got your hand up, haven't you?
Yes, I have. Can you hear me?
Yeah.
Yeah.
Okay, that's great. Thank you very much, Andy. Yeah, this is a question, I guess, related to the previous one. How many people actually, just around the software and the code, looking at sustainability within the code, how many people actually engage with that? If they already have a built environment, do they rewrite everything, or is it more the case that people who are doing something afresh, they would redesign it with sustainability in mind, rather than redo something they've already got working? What do people do normally?
Yeah, almost always the latter in terms of new projects and being aware. Again, for very, very similar reasons that we've already discussed. So, every commercial package off the shelf and every kind of custom built application that these organizations have has been through a tremendous process and governance and design and review and so on and so forth. So, ripping out the heart of it and changing it from, Python to Rust is no small thing to ask. But
yeah, that's what I was thinking. I guess it's for most people, it's something they can't touch. They sort of work around.
Indeed.
And then do other things outside of that, maybe.
But even within that, there are things that can be done. So, an awful lot of stuff is written in Java, for example, and it's not an AWS technology. But let me just type it in the window here. But you can take Java code, and if you go and Google that phrase, Growl VM, there are ways of taking Java code and making it tremendously more efficient than it would be by default.
Right.
So,
yes.
There's still things that can be done without necessarily changing the code.
I guess, I mean, you must have enough partners who would be developing software for end users. I think they might engage with you from the word go to say, well, this is the sustainable approach to take, and then
not too much of that. There's not too much of that so far, because as you have probably gathered, and if you look at the history of AWS announcements, the sustainability pillar and the sustainability agenda are relatively new things. But I think as we discuss going forward, we're going to, there's going to be more attention on it, and rightly so.
Okay. All right. Thank you very much.
I think Matthew Taylor had a question as well, which is in the chat. That might.
Oh, right. I don't think I quite understand the question, Matthew. What were you thinking of in terms of control frameworks?
So the question really is that some of the big focus now from some IT departments to try to get more work done and allow businesses to innovate by providing what some people call citizen development capabilities. So so if I was talking about one of your rival platforms, I'd be talking about the sort of power platforms, etc. So this means that you've handed over to outside your IT department to business teams to rapidly develop and innovate and build lots of applications very, very fast. And clearly you need and the cloud really helps with that as well. And clearly from a sort of control framework perspective, there are some things you try to do from a technology perspective so you don't lose control. But I see this as perhaps a growth area in terms of where people might leverage the cloud next. I was just interested in your view on sustainability. It might come down to all the different components you've gone through and all apply still. But I was just interested to see if you had a particular viewpoint.
Yeah, so I think I would call your first point there kind of zero code tools, I would call them, I guess. But rapid application development tools that are writing stuff for you in the back end and you kind of never see it because you're dealing with a really neat kind of drag and drop interface. I'm perhaps oversimplifying, but that kind of thing. And of course, there's opportunity there to make sure that what is generated is as efficient as it can be from a sustainability point of view, and more so in terms of how it's deployed, which kind of brings me on to your second point. There's already quite a lot of guardrails and governance in large organizations in public cloud. They do not allow people to just deploy whatever they want. There are a lot of controls built in by the organizations themselves, whether that's in terms of permission policies or having active things going around, making sure people haven't provisioned certain types of things or done it in certain areas. And that certainly can be applied from a sustainability point of view, right? So you might put a rule in that says for all non-production things, I'm going to insist that you use Graviton. And you can do that in the cloud. You can have that kind of control. I oversimplify with my example, but you get my point, I hope.
Thank you.